Students, welcome to my YouTube channel. Today we will do quiz number 7 for the month of January 2025. This quiz will consist of questions from NET, NAF, REX and Tech. So let's start with today's question number 1. What type of weather can one expect from moist, unstable air and very warm surface temperature? Okay, so the air mass is moist, unstable and very warm. So what happens? Let's draw this. This is your land surface. And then we have solar heating happening on this land surface. We have solar heating happening on this land surface. Now, due to this solar heating of the land surface, the land gets the land gets heated up. As a result of this, there is a low pressure created on the surface of this land. There is a low pressure created on the surface. Why low pressure is created? Whenever, remember, due to solar heating, a land gets very heated. Due to that heat, there is a low pressure created. What is the result of that low pressure? The air mass surrounding that low pressure area will start converging at the low pressure, and after converging at low pressure area, they will start rising. There will be rising air currents. There will be rising air currents. This rising air currents will rise in the atmosphere to the extent of instability of atmosphere. More the atmosphere, more the atmosphere is unstable, more intense will be convective currents. These currents are called convective currents. More intense will be convective currents. Okay. So these are your convective currents. And why convective? Why the name convective? So it comes from the word convection. Now convection is the process of transfer of heat in the atmosphere, where the heat concentrated in the lower atmosphere is distributed to upper atmosphere. And how is it done? It is done by the help of convective currents. Okay, they start from the lower atmosphere, they can go well up to higher atmosphere. And in doing so, they distribute heat from the lower atmosphere to higher atmosphere. These convective currents are also the causes of eddies in the atmosphere. Okay, eddies in the atmosphere. These eddies are nothing but the turbulence that you feel when you fly during afternoon. Okay, during afternoons when the surface temperatures are very hot. Okay, and there are too many convective currents in the atmosphere. So you'll feel these eddies, bumps, turbulence in the atmosphere when you're flying in such kind of weather. Now, when these convective currents rise in the atmosphere, as these air currents rise, if they are unstable, they will go higher and higher. And when they go higher and higher in the atmosphere, they will be surrounded by cold temperatures. Okay, cold temperatures. Now, whenever air parcel is moist, okay, it is moist, it has water vapor or water content in it, and it goes in the atmosphere or in a air region where the temperatures are very low or very cold, automatically saturation will happen, and at certain point at condensation level, the condensation of that air mass will take place, and due to the process of condensation, the gaseous water vapor will change into clouds. Okay, the water vapor will condense and become clouds. Now if the atmosphere is unstable, the growth of these clouds will be the growth of these clouds will be too much or too high. As a result, the size of the clouds will go on increasing. The size of the clouds will go on increasing. It is due to this convective currents. This convective currents will build these clouds to higher and higher levels. Okay, and that's why in unstable atmospheric conditions we have clouds of vertical development. We always say we have clouds of vertical development. Why? Because this convective currents will keep pushing clouds above, okay, to higher levels. And why vertical development? Because these clouds are of very huge size when measured vertically. As opposed to this unstable weather condition, this is unstable atmosphere. Okay. In a stable atmosphere, the air currents are not that intense like in unstable atmosphere. Okay, so in a stable atmosphere, the air currents are limited. The air currents are limited. Okay, so due to the limitation of convective air currents, the clouds that are developed are layered clouds, are low level layered clouds. Sometimes you can also have fog suspended in the air. Fog suspended in the air. So that is the characteristic of stable atmosphere. And you will have high pressure, you will have high pressure on the surface area. You will have high pressure on the surface area. You will have high pressure on the surface area. And what is the circulation of air around the high pressure? It is always, the air always settles down in the high pressure area, and after settling down at high pressure area, it diverges away from the high pressure area. It diverges away from the high pressure area. At low pressure area, it will converge and rise. In high pressure area, it settles from high atmosphere to lower atmosphere and goes away from it. Okay, so this is the stable atmosphere with clouds of medium development or very low development. Okay, we can also get fog. But in unstable atmosphere, we have these clouds which have great development. So the answer is, if the atmosphere is unstable, we have clouds with vertical development. Now, more the instability of atmosphere, more intensive will be the convective currents, more will be the growth of the clouds, and these clouds will have great ability to produce heavy precipitation, hailstorms, lightning, thunderstorm. After that, great turbulence, wind shear, etc. Okay, opposed to that, the clouds which are produced in a stable environment or stable atmospheric conditions are not that harmful for flying. So answer will be fog and low status clouds. So that is a product of stable atmospheric conditions, continuous heavy precipitation that is relevant, strong updrafts and cumulonimbus clouds. So the correct answer will be strong updrafts and cumulonimbus clouds. Okay. So the which type of weather? So they are talking about which type of weather can one expect. So you will have strong updrafts resulting from warm surface temperatures and unstable air. Okay, and when that updrafts go in the higher up in the atmosphere, it will, due to the moisture in the air, it will create cumulonimbus clouds. Now these cumulonimbus clouds, when reach mature stage of their life, they will produce heavy precipitation or heavy downpour. We also call it showery precipitation. So the most, B is also correct, but B is the consequence of C. Okay, so we will select option number C, which is more appropriate. Question 2. Which would increase the stability of an air mass? So out of these three options, which option will increase the stability or reinforce the stability of air mass? Warming from below, cooling from below, decrease in water vapor. So the concept behind the solution of this question lies here. When you warm a surface, okay, due to the warming of that surface, a low pressure is created, due to which we have convective currents in the atmosphere. And those convective currents will give rise to turbulence, clouds of vertical development. Okay, basically instability in atmosphere. When we have land cooling, okay, nocturnal cooling, or when on a particular day the solar heating or the insolation received from the sun is not that great, we will have comparatively a land which is less heated than on a day when we have very strong solar radiation reaching the land surface. Okay, so in such conditions, when the land is comparatively cooler or during nocturnal cooling or due to less solar insolation, on such days we will tend to have a comparatively stable atmospheric conditions. Okay, so the origin of an unstable atmosphere and an unstable atmosphere is intense heating of the land. So we call it warming from below. What is warming from below? Warming from the land surface. Okay, we all know that our atmosphere is not heated by the sun, it is heated by the earth. So solar radiation as we see here reaches the land surface. After reaching the land surface, the land will give back this radiation. Okay, give back this radiation, and this giving back of radiation is what heats the atmosphere. Therefore, we say atmosphere gets heated from below and not from above. Okay, so the correct option A will be incorrect because warming will increase the instability of air mass. Warming will increase the instability of air mass. Cooling from below, that is the correct option. Decrease in water vapor. Now, water vapor has no direct relation to stability of atmosphere. Okay, the presence of water vapor is what will result in clouds. If you have huge water vapor in the air, we will have huge cloud developments or less cloud developments. But water vapor directly does not have any effect on the stability or instability of atmosphere. It's the temperature lapse rate, the environmental lapse rate, as well as heating, cooling from below, but not water vapor. Question 3. Assume there is an ice formation over the static vent during climb out. Okay. Question 3. Assume there is ice formation over the static port or static vent during climbing. What will the altimeter read? Now we all know, let's revise some basics. Your aircraft altimeter is a pressure is a pressure is a pressure instrument, right? And what kind of pressure does it need for its operation? It needs static pressure. What is static pressure? The ambient pressure or the atmospheric pressure surrounding us. We call it ambient pressure. So static pressure, the ambient pressure, right? Okay, and this ambient pressure reaches this altimeter instrument through what port? Static port. If this is your aircraft, okay, so we have static ports on both sides of the fuselage, on the left and also on the right fuselage. So on both sides of the fuselage, we will have ports called static ports. Static port. Okay. This static port, what will it do? It will deliver static pressure. It will deliver static pressure to the altimeter. It will deliver static pressure to the altimeter. In the altimeter, we have aneroid capsules. We have aneroid capsules, and these capsules are linked linkage mechanism to the face of the altimeter, the phase of the altimeter. So the static pressure is delivered to aneroid capsules. Okay. After reaching the aneroid capsules, the static pressure, these aneroid capsules are like vacuum. Okay. Pressure expands the capsule. Okay. Pressure expands the capsule. So as you descend, as you descend from higher level to lower level, what happens when you descend to lower levels in the atmosphere? The atmospheric pressure increases. So as you descend, atmospheric pressure increases. This contracts or compresses the aneroid capsules. This compression is indicated as descent as descent by the altimeter. Okay. Contrary to this, when you climb to higher levels in the atmosphere from mean sea level to 10,000 feet, 20,000 feet, so what happens? As you climb, pressure in the atmosphere decreases. Pressure in the atmosphere decreases. When atmospheric pressure decreases, the aneroid capsules will expand. Whenever there is atmospheric pressure, even now when we are conducting this class, there is atmospheric pressure acting on our body from all angles, from all sides. This atmospheric pressure this atmospheric pressure is tremendous in value, but we don't feel that atmospheric pressure or the weight of that atmospheric pressure is because even our body, the internal pressure inside our body is opposing the outside atmospheric pressure. Okay. But when we go to higher and higher altitudes, what happens? The outside atmospheric pressure acting on our body, the weight of it decreases in value. Okay, and therefore the atmosphere becomes thinner and thinner as we go away from mean sea level. So what happens when there is no pressure acting on the body? Our body will tend to expand. That is why even in meteorology we have studied when an air parcel rises higher up in the atmosphere, the air parcel expands in size, expands in volume. Okay, so the same logic here. So when you climb at higher altitudes, pressure decreases around the aircraft, and as a result, a less static pressure will be delivered to aneroid capsule. So less static pressure getting delivered to aneroid capsule can be interpreted to mean that less static pressure is acting on the capsules, and hence the capsules will now get compressed a little less than before. Okay, indirectly we can say in other words that aneroid capsules will tend to expand because there is no outside force of pressure trying to compress it or constrict it. So as capsules will expand, and this expansion of capsules is indicated to us as increase in altitude. Increase in altitude. Okay. So this is the basic fundamentals of altimetry. Now, it can happen that this static port, which is on both sides of the fuselage, can get blocked. It can get blocked due to some dust, dirt, insect, or anything else. Okay. Now, when this static port gets blocked, what will happen if there is blockage in the static port? Static pressure won't get delivered to your aneroid altimeter, right? If the static pressure won't get delivered, okay, in the event the static port is blocked. Now, if static port is blocked and you are on a climb bound, so in this question it states that your aircraft is climbing, okay, your aircraft is climbing, let's say from this level, from a lower level to a higher level. What will happen? Let's say we are at mean sea level. We started from here. Here the pressure surrounding the aircraft was 1013 millibars. At this place, the static ports are working fine. Static ports, okay, I am writing okay. So that means there is no blockage of static pressure here. Whatever static pressure in the atmosphere, that pressure is getting registered and delivered to your altimeter, and hence altimeter indicates correct vertical distance. If QNH is put, you will get elevation. If QFE is put, you will get height of 0 feet. Okay. Now during the climb out from this airport, at this level, the static port, the static port gets blocked. Let's say at this level the static pressure is 900 millibars. 900 millibars. Okay, 900 millibar is the static pressure, and the corresponding altitude is, let's say, 4000 feet. 4000 feet. Okay, so at 4000 feet, 900 millibar pressure level, the static pressure has got blocked. Okay, so whatever pressure was getting delivered to the aneroid altimeter will be what pressure? 900 millibar. Okay, now after getting that 900 millibar of pressure, the static port has got blocked. So what will happen as the aircraft continues its climb to a yet another higher level, this 900 millibar of static pressure where the static port got blocked at this level, that static pressure 900 millibar will get or will remain trapped in the altimeter. Okay, the 900 millibar pressure will remain trapped in the altimeter. So what will happen? The altitude indicated by a altimeter will be corresponding to 900 millibar. Will be corresponding to 900 millibar. So ideally, as you climb to higher and higher level, the atmospheric pressure surrounding you should decrease in value. So when you climb from 900 millibar pressure level to a higher level, the atmospheric pressure should become, let's say, 700 millibar, then 600 millibar, so on and so forth. The atmospheric pressure should go on decreasing. When atmospheric pressure goes on decreasing, that can be converted or interpreted as increase in corresponding altitudes. Increase in corresponding altitudes, right? But in the event the static port gets blocked, the level or the altitude where it gets blocked, the pressure at that altitude, whatever the pressure is at that altitude, will remain trapped in the instrument. And as a result, the instrument will show altitude or vertical distance corresponding to that pressure. Okay, doesn't matter you are at 700 millibar pressure level or surrounded by 600 millibar atmospheric pressure, that is irrelevant. If there is no way for outside pressure to enter your aneroid altimeter, whatever pressure was trapped before from since before, that will remain in it, and as a result you will get vertical distance, altitude, height corresponding to that pressure. So let's answer this question. What will happen when there is ice formation over the static vent, and as a result, as you are climbing and climbing, there is no provision or entry for new static pressure to enter in your altimeter. So altimeter will overread the actual reading, altimeter will underread. What is overreading? Overreading means indicating a value which is more than expectation or more than required. Underreading means indicating a value which is less than the expectation or less than the requirement. Option C says it will read 0. Option delta says it will read maximum altitude on altimeter. So C is wrong. Delta is also wrong, and alpha is also wrong. The correct option is Bravo. It will underread. So let's say your altimeter got blocked at the static port of the altimeter got blocked at 4,000 feet. Okay, and now you're climbing to a higher altitude and you have climbed to an altitude of 8,000 feet. So the altimeter in ideal scenarios should indicate 8,000 feet to you depending on the pressure around you. But since the static port of this altimeter got blocked at 4,000 feet, the altimeter, notwithstanding the fact that you are at 8,000 feet, will still continue to show 4,000 feet. Altimeter shows 4,000 feet. You are at 8,000 feet in reality, but the indication provided is of 4,000 feet. So there is a mismatch. So what has happened? Under reading has happened. The altimeter is under reading, meaning it is showing a value which is less than the requirement. So we call it bravo. In case of descent, opposite scenario will happen. In case of descent, the pressure at 8,000 feet will remain trapped in the aircraft or in the altimeter, and as you descend to lower and lower altitude, that pressure which was at 8,000 feet will remain trapped inside, and notwithstanding the fact that you are descending to lower and lower levels, the altimeter will continue to indicate 8,000 feet. Even if you reach 5,000 feet, 2,000 feet, 1,000 feet, doesn't matter. Pressure Pressure of 8,000 feet is in the aneroid capsule static port, so that altitude corresponding to that pressure will be indicated to you. So in case of descent, it will overread. In case of ascend or climb out, it will underread. Question 4. Below given shows the combination of instruments. Which combination can be grouped together as pitch instruments? What is pitch? Pitch is a maneuver of flight in which you raise the nose of aircraft above the horizon or descend the nose of aircraft, okay, or lower the nose of aircraft below the horizon, or maintain the nose of aircraft along with the horizon, in line with the horizon. So we say pitch up. Pitch up means to climb. Pitch down means to descend. And pitch straight and level means you're climbing or you're maintaining a straight and level flight in line with the horizon in front of you. So this is called pitch or pitch attitude. So to adjust your pitch, whether if you're climbing, okay, the pitch attitude of your aircraft will be above the horizon. If you're descending, the pitch attitude will be below the horizon, right? And if you're flying straight and level, it will be in line with horizon. Now, when you're flying VFR, you can look outside the windows, outside the aircraft, and adjust the nose of your aircraft with the outside horizon. But when you're flying in IMC conditions, okay, or bad weather conditions, there will be no way to look outside and fly with respect to outside points or outside horizon or outside view. Okay, so you will have to depend on the instruments in your cockpit for the entire duration of flight. So there are particular instruments which are meant for different purposes. Out of out of three pressure instruments and total of six instruments, right? Three pressure and three gyroscopic. Every instrument has a fixed primary purpose and secondary purpose. And that instrument should be used for that sole purpose only. Okay, so you have to memorize this, what instrument is used in what scenario. So it's a part of IFR syllabus. You can read Jackson book on IFR. That book contains in the initial chapters, I remember, there is a good detailed table in which they have grouped together pitch instruments, the primary, secondary instruments, banking instruments, primary, secondary, okay, so on and so forth. Then again, there are engine instruments for monitoring engine parameters. So for that also there are primary, secondary instruments. So now from in this question we are asked to identify pitch instruments. So let's check. Option A says attitude indicator. Yes, attitude indicator is your artificial horizon, and that is the primary instrument. Looking at artificial horizon, you will come to know whether you are climbing or descending or maintaining a straight and level flight. Airspeed indicator, yes, again, airspeed indicator is nothing but your angle of attack indicator. Looking at your airspeed, you will come to know if airspeed is increasing. That means if you have not increased your power and still airspeed is increasing, that means you have an attitude of aircraft which is in the descent mode. If speed is decreasing or slowing down, the attitude of aircraft is above the horizon or in a climbing attitude basically. So ASI is also a pitch instrument, but manifold pressure gauge. Now this instrument is an engine instrument. It's not used for manipulating or adjusting your pitch attitude. So option A is eliminated. Option Charlie. Now let's go to option Charlie before Bravo. It talks about altimeter, RPM, and ASI. So ASI, like discussed, is a pitch instrument. Altimeter is a secondary pitch instrument because when you adjust a pitch, let's say climb, you have a pitch attitude of climb. So during climbing, your pitch attitude will be above the horizon, and that will result in an increase in altitude. When you have a descending attitude, your pitch of aircraft will be below the horizon, consequence of which will be decrease in altitude. So altimeter is what will tell you about the pitch attitude of aircraft. If altitude is increasing, that means the pitch attitude is above the horizon. If altitude is decreasing, the pitch attitude is below the horizon. Altitude is maintained, that means the pitch attitude of your aircraft is straight and level. Your aircraft is flying straight and level. So altimeter is a secondary pitch instrument. So that is also correct. RPM, just like manifold pressure gauge, we have RPM indicator or tachometer in your aircraft, okay, which indicates engine RPM. So this instrument will not be used for pitch. This will be used to check your engine working or engine parameters. So option Charlie is eliminated. Option Delta, attitude indicator, yes. Altimeter, yes. But again, no, not manifold pressure gauge. So delta is also wrong. Option Bravo is the ultimate answer. ASI, attitude indicator, altimeter, and VSI. VSI, which tells us a rate of climb or rate of descent. So it can be used as secondary pitch instrument. So option B, ASI, AI, altimeter, and VSI are pitch instruments. Important question. Let's go to next question, which is question 5. On an IFR flight, a pilot emerges from a cloud, meaning a pilot comes out from a cloud to find himself within 300 feet of a helicopter. Which of the following options best illustrates the macho reaction? The macho reaction of a pilot. So in aviation, to enhance safety of aviation, to make good decisions and to minimize risks, there are 5 hazardous attitudes identified which a pilot can have, and we have to make sure that these 5 hazardous attitudes are not in us, or at least to minimize or to tame these 5 attitudes. These 5 attitudes in us should not be very very dominant in us. Okay, it is impossible to eliminate all these 5 hazardous attitudes completely, but we should take care that these 5 attitudes exist, and we should always introspect and check that these 5 hazardous attitudes are not behind our decisions, are not influencing our decisions. So these 5 hazardous attitudes are: first, anti-authority. So anti-authority, the one pilot who has anti-authority attitude in him or her is like, don't tell me what to do. Okay, so the outcome of anti-authority is you are not ready to listen to instructions, to ATC clearances, instructions, rules, regulations, and your attitude is like, don't tell me what to do, which is anti-authority, anti everything. So the solution, if you have this kind of attitude of, anybody who has this kind of attitude, that he doesn't have any respect or consideration for aviation accidents, incidents, rules, regulations, recommendations. So the antidote to this kind of attitude is follow the rules, they are usually right. Okay. Second hazardous attitude is impulsivity, doing everything instantly uh, just at the uh, at this like at the moment, without thinking, without analyzing your options, without assessing your risks. So that is called impulsivity, doing something quickly. Okay, so we have to, and the solution to that attitude is not so fast, think first. That means before doing something, think twice, weigh your options, and select the best option, best outcome, option giving best outcome. The third hazardous attitude is invulnerability. Invulnerability means I am invulnerable to anything that is happening outside. So accidents, incidents, or any negative situation can happen to my friends, can happen to others, but they cannot happen with me, they cannot happen to me. So this attitude is also not acceptable. It says it won't happen to me. Okay, that means I'm shielded from any negative situations happening in life. So it could happen to me. So if you go on taking risks, thinking that your luck is always very good, that only your friends have bad luck or only bad incidents can happen to your friends, but nothing can happen to you. So this is again unacceptable. This demonstrates you have invulnerability attitude. Question Correction. Attitude number 4 is macho. That is I can do it attitude. Okay, it's very good that you can do things. Always, it's good to have believe in yourself and to have a positive dialogue with yourself. But in that process, we should not overdo something and overdo some things to the extent that they become unsafe and risky. Okay, so antidote to this macho attitude is taking chances is foolish. In aviation, we cannot take chances. Everything must be planned in accordance with the rules and should be safe also. Okay, so unnecessary adventure should be avoided at all times. Option 5 or attitude number 5 is resignation. That means the give up attitude. Okay, anything bad happens or any, during your flight, any new event happens which you have not learned or you have not heard about. So instead of assuming a role of leadership, you give up and you tend to give in to the situation. So resignation is what's the use of give up attitude or laid back attitude. So the antidote to this attitude is you are not helpless. You can make a difference. So you can act, make a positive difference, bring a positive change to your flight outcomes. So these are the 5 attitudes, and all these 5 attitudes, some way or the other, endanger aviation safety. Okay, so if you take aviation accident studies, case studies, and if you have to name one attitude behind every accident or incident, most probably you will find attitudes one of these 5 attitudes or many of these 5 attitudes. Okay, these attitudes are behind many of the bad things happening in aviation. So now in this scenario, the situation given to us is that IFR pilot emerges from a cloud to find himself at a collision course of a helicopter. Now out of these 3 options, which one is macho attitude? He is not too concerned, everything will be alright. He flies a little closer just to show off. He quickly turns away and dives to avoid collision. So the correct option will be option Bravo, macho attitude. He flies a little closer, even closer, just to show him. Okay, so this is macho attitude. I can do anything attitude, taking chances attitude. So that is foolish. So option A and C are wrong. Bravo will be the correct option. Option A is more like invulnerability. Option C is quickly turning away and diving to avoid collision. So that is even diving at such times is not recommendable. But depending on the severity of the situation, the pilot is the ultimate decision maker. So C can be proper, but A demonstrates invulnerability. Option 6, maximum cumulative time, total time that emergency locator transmitter may be operated before its battery is recharged is how much? So this is a factual question you must remember. That answer is 60 minutes. So if you have used emergency locator transmitter for a duration, okay, cumulative duration of 60 minutes, today 10 minutes, tomorrow 30 minutes, the next day, day after that, another 20 minutes. So once a cumulative operation is equal to 20 minutes, 60 minutes correction, you must recharge the battery of emergency locator transmitter. Question 7. When in the vicinity of a VOR, which is being used for navigation on VFR flights, it is important to do what? It is important to make 90-degree left and right turns to scan for traffic. That is wrong. So here they are talking about flying using VOR Airways, Victor Airways. So there are many VOR stations that you can see everywhere, and you can see this black airways, which are nothing but VOR radials. Now let's, for the purpose of this question, let's take two radials. Let's take this particular radial, and let's take another radial which is nearby, something like this. Okay. Now there, it can happen that on these two particular radials there are two different aircraft. Okay, two different aircraft coming inbound towards the VOR, approximately same level. Okay, coming inbound towards this VOR at same level. So this VOR station is one major hotspot where many aircraft tend to converge and then they transition to the opposite radial and fly away from the VOR. But if two aircraft are at same level, approaching the VOR at more or less same time, same altitude, speeds are identical, so that can create a safety situation that can endanger safety. So you have to be extra careful in such scenarios. Okay, so option A is eliminated. Why? To make a visual scan for traffic around you. You don't need to turn your aircraft 90-degree left, 90-degree right. A total 90-degree change in heading is not required. You can just look outside your window, outside your windscreen, and check for traffic. If you want to check for traffic, if you're flying a high wing aircraft like a Cessna 172, you can check for traffic above you by just tilting your aircraft, rolling your aircraft left and right, raising the wings up and down, bringing the right wing down, raising the left wing up, raising the right wing up, and bringing the left wing down. So that way you can scan traffic, but you don't need to make a total 90-degree heading change all of a sudden. Also, if you're flying a Victor airway or any VOR airway, you cannot deviate from your track, okay, from radial. If you make a 90-degree change in heading, that is a big change. You may tend to deviate from your radial, okay, so that is also not acceptable. You have to follow the route that you are flying very strictly. So 90-degree left and right turns is not recommended. Option B is exercise sustained vigilance to avoid aircraft that may be converging on the VOR from other directions. That is okay. Option C is pass the VOR on the right side of the radial to allow room for aircraft flying in the opposite direction. So that is wrong. So this is nowhere given in the theory. So a correct option is option Bravo. Be extra vigilant, be extra careful, okay, be prepared whenever you are approaching a VOR station. Maintain a listening watch on RT. Listen to ATC communication. Listen to what other pilots are talking. Okay, so this way you can avoid conflict or threat. Okay, so and option C is wrong because this is not what we do in life. Passing the VOR station on the right hand side of it on radial to allow the opposite traffic to use that radial. So that is not the recommended way. So option Bravo is the correct option. Question 8. Which airspeed would a pilot be unable to identify by the color coding of an airspeed indicator? Very good question. So the answer will be the maneuvering speed. Okay, so this is your airspeed indicator. On this airspeed indicator, we have color ranges, and every color means something. It has some meaning. So a green color range is normal operating range. The white one is flap operating range. The yellow one is the caution range, and the red line is the never exceed speed. So never exceed speed, a red line is indicated. After that, power of stall speed. The power of stall speed. Now the power of stall speed is indicated by your VS1, the lower limit of the green arc. Okay, power of stall speed. So that is also indicated, but maneuvering speed, nowhere here you can find maneuvering speed. Now what is maneuvering speed of aircraft? The speed at which you can deflect the controls of the aircraft to its maximum limit. Okay, so that speed varies with the weight of your aircraft. As aircraft becomes heavier and heavier, the maneuvering speed will increase in value. As aircraft becomes lighter and lighter, it decreases in value, and hence it becomes impossible to show maneuvering speed on the airspeed indicator in some form of color. So correct option will be option Charlie. So maneuvering speed is not shown on the airspeed indicator by some color coding. Okay. So with this, I hope you have understood this lecture. You have learned something new today and you were able to answer maximum questions, or I will be happy, most happy if you are able to answer all the 8 questions on your own. So keep watching these videos. Do the other quizzes that are available on this channel as well. If you have liked this lecture, hit the like button. Subscribe to this channel if you haven't, and share this video with all your friends and colleagues. All the best. Keep learning.